Welcome to this presentation of the collaboration project HIS, Humanizing the Sustainable Smart City. My name is Hedvig Källström and I'm the coordinator. The central goal of smart city development is the well-being of its citizens and at the same time enabling a sustainable society and environment where resources are used in a balanced manner. Digitization is a key component of this, providing tools to collect info, connect people and support decision making. In this project, we develop digital tools and methods from many different domains in order to achieve a sustainable smart city without compromising the well-being of its citizens. This project is a highly multidisciplinary research effort ranging over 3 schools at KTH. Myself, I'm the coordinator and I have 6 PIs in the project from different schools at KTH. The research team have the ambition to develop a new research area in urban development, well-being in smart cities, focusing on interactions in cyber-physical human systems, based on human decision-making on an institutional, individual and neurological abstraction level. The application in focus are the smart cities of the future, which is our main application area, as these are complex cyber-physical human systems. The project will develop a framework for capturing and modeling interactions and dynamics in these systems. These models can be used to make informed decisions on how to design smartest city infrastructure, decision processes and architecture in order to maximize well-being while maintaining the sustainability of the city. Much earlier work on smart city development has focused on the system level using a top-down perspective. At the same time, there is a lot of work in other highly overlapping fields such as cognitive psychology and neuroscience, econometrics, human-machine interaction, etc., on human behavior and decision making and how decisions on meso and micro scales, so also on the level of individuals, not only on the macro scale, which is a city, but also on the level of individuals and also inside an individual's brain, interact and create emergent patterns on a larger scale. The central idea in HIS is to employ such approaches from other fields for smart city development. We address 3 research questions. The key challenge for human choice and decision models is how to account for subjectivity based on individual perceptions and affected to some degree by internal states, such emotions. Decision models therefore need to balance rational and irrational components in some way in order to provide predictive tools for human choices in a sustainability context, in general smart city context in particular. We develop from standard frameworks of behavioral economics and instead we depart from standard frameworks on behavioral economics and instead draw from recent neurocognitive results. Secondly, human decision-making is a complex process that can be studied at different levels of abstraction. Our ambition is to gain insights into the brain mechanisms underlying the cognitive phenomena involved in human choices. We intend to investigate which aspects of the complex decision-making and behavior can be accounted for by mechanistic brain models. In other words, we aim to learn what are the key limitations of the neurocognitive approach to explaining human choices in specific scenarios in a city context. Although individual choices and actions are critical for the overall behavior, it is well known that human actions are directly and indirectly affected by choices and actions of others. That is, the human social context consists of evolving interactions between individuals on different levels. Our first step here is to study interactions on a personal or private level among friends or acquaintances, with specific goal to understand sustainable lifestyle choices, and in particular how these choices are affected by interactions within a social network. We are in the process to explore a variety of areas. Firstly, we develop a coherent urban science theory basis for the novel bottom-up paradigm. This theory goes beyond conventional modeling and prediction in urban science, which is an established research domain, to characterize these kind of complex emergent and adaptive systems that we see here. Secondly, we bring in methods from information theory, decision and control, human-machine interaction, artificial intelligence, and neuroscience for modeling of human behavior and decision-making at different scales, from neuro up to city scale, and employ them in the context of this new urban science theory to achieve models of how the decisions of humans and artificial agents affect each other and interact with the environment. Last, we need to evaluate our models. For the smaller scale scenarios, we use data and testbed scenarios from other projects. And in HIS, we focus our testbed development efforts on a larger scale. So, for example, a large part of our tests relate to the Living Lab here at KTH. And we also have scenarios relating to a larger city scale in collaboration with Stockholm Stad. Our work is focused around 6 case studies. The goal of case study A is to examine how digital tools are being developed and applied at various scales to produce new insights about urban dynamics. And in case study B, there we examine cities as social networks and employ methods from network theory. How human social choices define these networks and how digital tools applied at various levels shape urban interactions and change. In case study C, we move down in spatial scale a bit and focus on a building. So here we look at the Living Lab scenario, and we apply automated approaches in this building scenario to isolate correlations among a large set of sensors and events in the building and showcase the possibility to find, for example, causal relationships and develop models with some predictive power about the chains of events in this building. The aim of case study D, again on even a lower spatial scale, is to gain better understanding how decision making and its behavioral consequences at a population level can be modeled as an emergent effect of different interaction between individuals with their own goals, motivations, and experiences. In case study E, The aim is to, here we have moved even further down in spatial scale and look at one individual. So the aim is to gain novel insights into computational principles of representing and processing neural information in the brain. So despite a relatively large body of experimental data, there is no well-established theory how populations of neural cells in the brain reliably encode information about complex environmental stimuli and how neural network circuits are optimized to make this information behaviorally relevant. And in our last and sixth case study, the aim is to analyze the role of households and their practices in relation to digitization of the energy system and the transition to a sustainable society. Thank you for listening, and please visit our webpage at www.his-digitalfutures.se for more information about the project.